Hi guys, welcome to my channel, and today let's talk about Leetcode problem 114. So here is the problem, and as you can see, you are given a binary tree and you want to turn this into linked list. So for this kind of problem, my recommendation is that you start with a very simple binary tree, like a binary tree that has three nodes, and then try to move that around, try to get a linked list. You will gain some insight from doing that, and then apply that on a bigger binary tree and see if you can generalize it. That's the way I approach this kind of problem, whether it is a the graph problem or dynamic programming problem. You always start with a small one and then try to see if you can find a pattern. Yeah. So this is how I approach this problem initially. So you start with very simple binary tree, 1, 2, and 3. So how do you flatten this binary tree into a linked list? So basically you would have to move 2 to here, and then 3 should go to the right, so right child of this node 2. So well, you set this current node points to this 1, and then you want to find the rightmost node of the left subtree. That would be 2. So you set that equal to p. So p points to this 2, and then you also set this guy. This is just current node's right child. So if you set current node dot right, this will point to this guy. Now you can set p right equal current node dot right. What that does is you will create a so this guy doesn't have anything. This guy has no right, no left child. But if you set p dot right equal to current node dot right, you will set points to this guy. And then what do we have? Well, we have this guy initially. Now we want to move 2 and 3 to this, to the right, so that we have flatten, so that we have a linked list with no left child. So how do you do that? So this one is still current node. So we have a current node dot right is, if you look at here, current node dot right is empty, it is null. So we set that equal to current node dot left. That means the right child will point to this guy. But notice that we had current node dot left that points to this guy, and current node dot right points to this guy as well. So we must have this current node dot left set to none. Otherwise, we don't get the right answer. If you do this, what that does is you basically cut this linkage, cut this relationship. So that's this is a very simple problem. You only have 3 nodes, but yeah, let's try to generalize this. So here you have 7 nodes total. So if you look at here, we first have to find this guy p, the rightmost node in the left subtree. How do you do that? Well, you initially set p equal to current node dot left, so that will be here. P will be here. Now then you would have to use the while loop to go all the way to the rightmost node in the left subtree of 1. So if you had like tree like all the way here, you initially set p equal to current node dot left, then p will point here, and then you set, as long as p dot right is not equal to none, or in Python it is none, then you set p equal to p dot right. What that does is p will move here, and then all the way here. Like it will keep going on and on and on until until this is not true. So in this case, p dot right is not none. So p will be here. Now when p is here, what is p dot right? P dot right in this case will be none. So we exit while loop, and p is here. So that's how we get here. And then current node.write is here, and as you saw in here, where we had p.write equal to current node.write, we do the same thing. Then this guy will move here, and then we create this linkage. Now we do the same thing where we move all this left subtree to the right subtree, and we do that by current node.write equal to current node.left. And don't forget, we must set this guy equal to, we must cut this relationship. When we do that by setting current node.left equal to none, then this guy will be, this linkage will disappear. Then we will get this. Okay, and we have to find this guy again. Okay, so we move current node to this guy, and we do that by setting current node equal to current node.write, and then we use this relationship, this while loop, to find the p will be here. And we do the same thing. We move this right subtree by setting p.write equal to current node.write. Then this is what we get. And we do this part here again here. Then we will get 1, 2, 3, 4, 5, 6, 7, and this guy will disappear. Yeah, this guy will just move here, and then we cut this linkage. So this is what we get. And now notice that for both node 3 and node 4, we do not have the left children. So we want to be here. And then our p in this case will be this guy. So how do you skip all this guy? We first check if current node.left is not equal to none. In this case, current node.left is not equal to none. However, in this case, for both 3 and 4, this statement is false. So if this is false, then we shift current node we set current node equal to current node.write. Then what that does is this guy will move here, and they will go here, and at here, because current node.left is not equal to none, current node will point to this guy, and then we will do the same thing to find the p, and then we move this guy to this guy's right child, and then we move this left subtree to the right subtree, and that's it. Yeah, so so as you can see, the main takeaway from this problem is that you want to try very simple model and then see if you can get an insight. If you get an insight, you want to try a slightly bigger model and then try to come up with generalization. This approach works in really pretty much anywhere in Leetcode problem, and I highly recommend it.